Welcome everybody. This session, basically we are going to see how we do Python Flask application and setup of it using SRE framework, SRE toolsets, and how it can helpful in your industry setup. And later we will see that how we can add value to your organization if you're working on any of these applications or you want to learn these applications going forward. So what we are going to do is we are going to, as I already mentioned, we are going to take Python Flask application. We are going to deploy that our Kubernetes platform. And I'm going to talk about each of these tools one by one. So we are basically going to use 4 tools. We'll start with GitHub, which is basically your source code management tool to store your Kubernetes configurations. We are going to use that. And then we have Atgen A2. Basically, it's an automation tool doing continuous integration and workload automations. So we are going to integrate that with GitHub. This tool has a capability to monitor your repositories or code stored on GitHub and trigger processes based on that. So that feature of the tool we are going to use ahead. Then we are going to use Terraform, which is a configuration management tool, and that will basically use to deploy our application, which is a Python Flask based application over the running Kubernetes cluster. Of course, it will pull images from Docker Hub. So we already have 2 images available of a Python web application, which works with the Redis database. So whole throughout a lot of technologies I have talked in last few minutes. So let me just run you through about the tool sets which we are going to use and why they are going to come into play. Now in the Python Flask application deployment, so our first tool which we are using is a GitHub, as I mentioned, because this is a place where we are going to store our repository. So I will actually show you our repository right away. So this is our GitHub repository. The SpyWeb is the application name we put up. It's just a simple Python Flask application. And in that, the major code which we have is basically a Terraform code, which does deployment. So let me show you that. So this is how we use a provider. In a Terraform, we do have a lot of providers to interact with multiple platforms, and Kubernetes interaction, it has a Kubernetes provider for that. Same way, if you work on some other cloud platform like AWS, Google Cloud, or DigitalOcean might be, or Microsoft Azure, it has providers for each one of them. And if in-house you have a virtual machine architecture and you're using ESX or vSphere, vCenter, hypervisor sort of tools, it has platforms for that. So Terraform gives you automatically written providers to interact with various type of infrastructure providers using all written in a Go language. It's a HashiCorp totally free tool written in Go language, so very easy and customizable. A kind of a standardization across the enterprise we can get with it. So one requirement from SRE side is a standardization at an enterprise level for your deployment solutions. We have multiple type of solutions, and that's where Terraform comes into play. So we define our configurations in it, and it's basically a JSON format language which you have to adopt for it, or you can use YAML as well. So any of the markup languages commonly used, JSON or markup works with it. Here we are basically having Python images, you can see. So Python images basically are already there on a Docker Hub repo, and it can be basically pulled up. This is a Python web application which connects with the Redis in a backend. So we are going to use this. The second tool in the picture is basically Atgen based platform, which is Atgen A2, which is an automation solution. And I just log into it and I'll show you kind of a dashboard of it. So this is how the dashboard of it looks. This is a workload automation solution come in continuous integration solution. So what it does basically in our case study is integration with GitHub. So if any changes done in this Git repo, this has a predefined jobs which is into YAML format, and you can basically trigger, they automatically get trigger, and finally they deploy the application using this configuration over the Kubernetes. So that's how the full cycle works. You need a Docker registry for that because Kubernetes does require that. That is kind of a must for this sort of a solution. It can be a global Docker hub, or you might use something in-house. At the same time, this tool gives you a flexibility to plan your workloads more effectively. So I'll basically show you now that how we implement this using the integration of full tools. And our course line, which is there, is basically covers all these tools and this integration in a very vast way. So we'll consider Python Flask application here as given in a Docker image. Now, the last tool which I have in my series is basically, I have talked about Atgen A2 as well as the GitHub. Terraform basically gives you a big change in an organization. See, if you look at the organization from the big detail point of view, you have a multiple type of infrastructure. You have a Windows platform, you have a Linux platform. You, as a big organization, if you go to any organization, you'll see one common thing. ESX is there, vSphere hypervisor is there, some sort of a private public cloud is there. Some places we have an OpenStack as well. Then we are moving towards containerization using Docker, Kubernetes, or OpenShift. So all these solutions can be standardized at a deployment level. If I'm deploying on a VM, my plan is different. If I'm deploying on a container like Docker, my plan becomes different. And if I'm deploying on a cloud, my plan becomes different. So SRE model actually pushes to you towards standardization, where Terraform actually plays a big role. You have other tools similar to it, like Ansible is one solution which can actually be replaced, but each has their own pros and cons. Terraform is a very, very lightweight, even compared to Ansible. And at the same time, it's more scalable as much as infrastructure and operations teams are concerned. That is the advantage it provides. The second advantage it gives us is the desired state thing. So it maintains in the multiple times you run your code, it is capable to maintain the state of your code. So the operation headache in terms of tickets and resolution, restarting the applications as a production support is basically reduced to a great extent by using these tool sets. And it's written in Go language by HashiCorp, a free tool completely, and vastly used by a lot of people. Kubernetes is one of the, I would say, the future in terms of IT infrastructure, or have already started replacing your virtual machines architecture itself. And it allows you to create clusters at an application level. At the same time, it gives you high availability and disaster recovery mechanisms. So for infrastructure teams, for operations teams, this is kind of a big change, which is, you will see in 2025 or so, that if you will nowhere using vSphere, vCenter, or hypervisor. Will everybody will move towards either use Kubernetes or OpenShift, basically containerization. And Kubernetes is a Google software, predominantly written to provide clustering high availability solution over the Docker, and it has role-based access control, auto scaling, liveness, and storage features as well. So very, very comfortable tool if as a future to move towards. We are going to have Python Flask application with the Redis. We have two Python web application images, PyWeb 1.0 and PyWeb 2.0. 1.0 is basically connects with the Redis and counts the application. Let me show you that, and then it will be more clear to you. I'll walk through this on a later section. So what I'm going to do now is, these are few application jobs which are defined in a YAML format. To show you their code, let me show you how they look like. These are Adgen integrations basically. So let me show you that. So this is our integration, and I'm showing you the kind of a code of it. This is a pure YAML code. So this basically polls every 2 minutes to our GitHub repo, and fetches the changes. If there's a changes, this triggers. Otherwise, it keeps on waiting. So that's what the condition actually means here. So this is kind of a monitoring of your repo happening every 2 minutes polling frequency and maintains your repo. And if it is basically there's a change, this will trigger the deployment part of it, which is a Terraform call script. So let me make a change here, and as of now, I don't have anything running over that Kubernetes. It's just a plain vanilla architecture I can show you here. It's no application running at all. It's just a default Kubernetes cluster service you can see. So what I'm going to do now is I'm basically going to make a change, and that will show you a results of it. This is my code. This is a Terraform code written in JSON format, and this is my GitHub repo. It's kind of a live. I'm making a change. So I'm making it to go to PyWeb 1.0 version. Here is my Docker image, which is basically PyWeb 1.0, and the second container is a Redis one. So two containers managed. So I'm just making this change and I'm committing. So that's kind of a comment section for the commit, and I'm making a change. You can see now it is recently changed just now. You can see that, and that will actually trigger the application. Let me go to the main page of it. It was done a few hours back, so let me wait now. It takes 2 minutes because the polling frequency is 2 minutes, so I have to wait for 1 minute, one more minute here. Yep, it is now, and you can see it is running now because polling every 2 minutes. So this time can be changed. It is up to me what I want to define. You can kept it to minimum every minute. This deployment is right now going on. We can analyze this detail also. I'll show you that. You can see it's gone to success. And if I want to see the details of it, I can just click on here. This gives that this took nearly 1 odd seconds or 1 odd minute sort of a thing. Little less than that though. There's no dependency tree because this is independent, and I have an output log which tells me what all it did. It started cloning the PyWeb repo, you can see. So it's basically notice that there's a change in the repository, and then it downloaded or cloned the code from there. You can see this all is a logs of it, and here it started Terraform HashiCorp initialization, and then it went on to create. You can see here creating the service and the deployment. After that, it gives us a public IP also, and this is a public IP. And if I take this URL, I just click here and go to the browser, I will get the Flask sample app, which is running with the version 1.0. Remember, in the code, we have basically rolled it out to 1.0. So this application will only run if there's a code change. Otherwise, this is not going to run because of the dependencies we have here. So I'll just show you that dependency part also. This is defined at the box level, container level. And if I open that, I have this red now, means this dependency is not meeting. When it is going to meet, it will show you in a green color. So the colors coding is there. So this actually deployed the application in a background. If I go to Kubernetes here, I have this started a deployment running, a pod is running, having two containers, and I can see details of this pod also. Let me show you this pod. Pod means container, guys. Those who are new to Kubernetes, a pod actually means group of containers, and this is two containers running in it, and it's running since 2 minutes 15 seconds since I started. And this is the URL which I was accessing over the web page. Now let me just show you description of this board, which is running. kubectl describe, that's basically Kubernetes command line. If I do this, that gives me almost everything. And let's analyze that. So this is the name which is there, and application is running on one of the cluster node of Kubernetes. Remember, Kubernetes is a cluster. Cluster means group of servers. So one of the server is called minion in the group having this IP. That is a place where these containers are running. This is the Docker IDs and Docker images. Image being used is a PyWeb 1.0. If you remember, same we have changed in the code. And then if you see the events part, you have a container. This one, it pulled and it started, then it pulled the Redis and it started. There was a question that how Kubernetes can fit in. Let me show you a very good thing about Kubernetes. I have, let me go to that server, which is Minion, where it is running. This server, which is Minion. I'll just go there and I'll show you interesting things there. So I'm on the Minion, and if I see container IDs, I can easily analyze this is running, or I can verify from here also. My container ID is 8732 something. So here you will see that 8732, right? So this is running. Now what I'm going to do is I'm going to actually kill it, deliberately kill it, just to see the operations part. So this was my container ID. I copied it. So Docker kill this container ID. I'm stopping it deliberately. I was talking about how operations can benefit automatically. So I just did stopped. And soon you will see just 5 seconds back, it is newly started automatically. And think about the time. I just stopped and it's already been 5 seconds. So you can see how quickly it recovers your application. And here also, if I see the describe part of it, I will see the logs. Container was missing and it started again. And here also the container ID will be changed now. It is now 2B something. So it automatically changes the things and it validates that this is the container ID now. So it is smart enough to analyze all those things and recover things. So that's the thing I was talking about. My application will never fail because of this. That's what Kubernetes provides us. So every tool gives its own advantage. Terraform gives you kind of a desired state for different type of infrastructure principles, configuration management for infrastructure. Kubernetes gives you kind of operations overhead reduced, automatic recovery, and higher security. Atgen A2 gives you integration and the workload automations. Git, of course, is the source code management. So that is the one part I want to talk about. Now you can see it's running, and the app which actually started at 2054 in as per my clock. So it is running. It has run after that. It's doing polling every 2 minutes, but it's not running because there's no code change anymore. So what I do now is I will do a code change to the upgraded version. Let's say my application is updated. I have a new image and I want to do the code change now. So I'll just go to the code file, which is here, and I will change it to 2.0. It's just a heading I'm writing. This is a comment because it's a hash. Actual change happens below. So 2.0, and let me update to 2.0, and let me write that as a comment, and then I'm committing the change in my GitHub. So it's done. You can verify it. Just now it's done. Now let me wait for it to take because the 2-minute polling interval. So it started.
Hey, Sagar.
Yeah, right.
Just one question while that is coming up. So I also come from a Windows world, like Iron. My question is, if we had to set up these applications independently in a traditional VM environment, it would take us anywhere between 6 to 8 hours, right? Going through, even if the procurement was completely automated, to add it to a traditional load balancer, it would
Mhm.
definitely take 6 to 8 hours in any kind of environment. So,
Uh,
are you suggesting that in a container world with Kubernetes, I'm also pretty new to it. If I want to add capacity or recover service like ones you were showing, it takes less than what, 2 minutes is what you took.
Absolutely. I'm saying not even 2 minutes. I'm saying seconds.
Okay,
So not
okay.
even minute.
And
So and
what?
yeah, go ahead,
Go ahead.
Rohit.
Go ahead.
And that's the basic benefit of Kubernetes. I was just saying that. So go ahead. You were saying something.
No, I was just curious, considering this is very new to me. How
Uh,
does the load balancer on top of this work, on top of containers?
in case of a Kubernetes, we have basically something called as a kube proxy. It's defined within as a component of Kubernetes, and what it does is it has capability to do the load balancing. So we have a Kubernetes services. Let me show you something. In here, I'll show you that. So if you notice, I have one more section, which is this service.
Right?
Now, this service is actually the end user URL and the endpoints created for load balancing.
Okay. Okay. So the public IP is essentially the load balanced IP.
Yes.
Okay. Makes
And
sense.
it has capability within the cluster itself. And so there's a component called kube proxy in Kubernetes, which allows this to create that. So, and finally, you get external IP, which basically is a load balancer IP. Just like we have a VIP in our companies, virtual IPs. So
Right.
that
Right.
routes to multiple VMs as of today. Uh,
That's correct.
so, so same way, Kubernetes has a component kube proxy which gives you virtual external IPs. This public IPs, we call it public IP or external IP. They are capable to do that routing internally at a container level.
Perfect.
Find
Thank you,
that?
Sagar.
Okay, welcome. Now this is completed by the time we are talking, and if you now just refresh, you will see 2.0 version coming up. By the way, this application actually count your number of requests. So you have one request here. If I refresh the application, the number changes. You can notice that 3, 4, 5, and also based on number of refresh, it just saves the count in the Redis data store. So that is how quickly your deployment go. In the case I use Kubernetes and this whole pipeline basically. So you can see I just went from 1.0 to 2.0 within span of seconds. In the background, containers started, stopped. SRE, if I come back to that core topic now, SRE is about learning these tool sets, applying in a proper way. If you know these tools, of course, you can then apply. And there are bigger changes into it also, just like from the virtualization to containerization is the one change, and then a production readiness of containerization, which is Kubernetes, is another change. Then thought process about writing code, because if you look at our infrastructure teams today, they know a lot of commands, they keep on running a lot of commands. Be it Windows, you do a lot of clicks. Be it Linux, they write a lot of commands. So what these tools are going to provide you is a one-time effort. Just like take an example, if I am from Windows, how many times a Windows admin or a Windows user basically creates a user? He goes to control panel, user management, and there he creates a user. How many times in his career he does that? How many times he enables something like IAS, a web server over the Windows? How many times he installs SQL over the server? How many times he do task scheduler things? So all these activities are basically created from the intention that we will no more run all those commands manually. Be it Windows or Linux, it doesn't make difference at all when you come to all these tool sets, because these tool sets are capable to interact with Windows as well as Linux in a same way. Just like this application, which is I was showing you. Let me show you the code here once more, because that will give you a bit of clarity. What I was showing you is each of these tools, you take it Kubernetes, Terraform, Atgen A2, or GitHub. GitHub, anyways, is for applicable for all platforms. Atgen A2, again, applicable for all platforms. It doesn't make difference between Windows and Linux as a front end. So you will see same logs, same type of applications, same jobs, be it whichever. Let me show you the diff. So similar kind of a YAML works for Windows. Similar kind of a YAML works for Linux. It is just the node part which changes because that's a server name you mentioned here. So for this tool, I won't say any platform dependencies at all. So be it Linux or Windows, it works same fashion. So we basically had an application which is running Python with the Redis database. You have seen that change. Count the number of refreshes. Two versions of Docker images, which is highly available on the web. If you need the links, I can give you those images as well if you want to try. In fact, I'll mention that in a chat window itself. Then both the images was basically connecting to Redis to store the accounts. We used Terraform Kubernetes configuration. The code was stored, which was a Terraform code written in a HashiCorp language, which is JSON. We have stored that over the GitHub. Adgen A2 automation basically checked out that code from the GitHub, monitor the changes, and trigger the deployment using Terraform. And Terraform deployed that over Kubernetes in a real time without any downtime in a real sense, if I tell you. That's how smart these tools are.
And contact us using our website www.adgensoft.com, LinkedIn, Twitter, Facebook, YouTube handle. We have Adgen Automation. Do follow and subscribe us. You can write to us using our email ID info@adgensoft.com. Thank you for watching the video. Have a good day. Bye bye.